Andy Johnson. We are looking at just some of the basics in educational research. We're looking at statistics, just some basics that you need to know. You don't need to know the whole statistical analysis. You just need to know the basics to become responsible consumers of educational research. Statistical analysis serves two functions: to describe and to infer. Descriptive statistics are used to describe an existing set of data, and there's three major types of descriptive statistics: measures of central tendency, frequency distribution, and measures of variability. So measures of a central tendency, describing a set of data with a single number. The mode is the scores most frequently obtained when you have a set of data. The medium, a set of data, a list of scores where 50% is above and 50% is below, and the mean is the arithmetic average. Frequency distribution is a way of organizing information. All the scores attained and how many attained each scores. This is frequency distribution. These are the scores on the exam and the number of students who scored each. Frequency distribution, and for larger numbers of scores, and you can put those on a graph. All the scores that were attained and how many attained each score. Frequency distribution, and you can graph those as well. Now, measures of variability tell us about the spread of scores and how close they are. You've got range, variance, and standard deviation. Range simply tells the difference between the highest and the lowest scores. For example, Mr. Smith's 8th grade class, lowest score 50, highest 99. The range is 49. Variance is the amount of spread among the test scores, and that's used to calculate standard deviation. This is with a small variance. You see all the scores bunched here. Scores with a large variance, the scores were spread out. Standard deviation tells us how closely these scores are clustered. It's the square root of the variance, if you need that, used to describe the dispersion of scores, and we get this nice bell-shaped graph where we see in a normal distribution, a normal population, you get this bell-shaped graph where 50% are above and 50% are below. If it is a small standard deviation, you get this tightly. If it's a large standard deviation, you see the scores are more spread out. And this is a normal distribution. You get the bell-shaped curve. Take a look at that again. In a normal distribution, a normal population, 68% is right here. This means in any school that 50% of all your students are going to be below average. That's what average is. This is the first standard deviation, the second, and the third. All you need to know is 50th percentile. This is this is the 90th and 100th percentile up here. All right, so 50% of the scores are below, 50% are above. 13% are more than, and then the rest. You get the idea, okay? Inferential statistics, statistical analysis used to determine how likely a given outcome is for an entire population based on a small sample size. Based on this, we can generalize to a larger population. Now, here are the most common inferential statistical analysis. But for our purposes, we are looking just at statistical significance. This is a procedure that demonstrates the likelihood that differences were caused by more than chance or sampling error. The differences are, if it's too close between one and another, you can't say that one thing caused another. But after the treatment, if there is a difference between control and experiment, and that difference is statistically significant, you can say that the difference between the groups were more than could happen by chance or sampling error. That's why when we look at studies, we don't look for differences, we look for statistically significant differences. For example, we see this nice statistical significance, all right? Difference between, this is good, from 2019, all right? If there's a difference and it's statistically significant, we have a large population here, and we notice that the difference between 2017 and 2020, that's statistically significant. This difference is more than could happen by chance. This is not in 2009, okay, there was a slight decline, but it wasn't statistically significant. Oh, in 2015 to 2019, score of 217, that is statistically significant increase. That's why we don't look for differences, we look for statistically significant difference. And you're saying, wow, it's only 2 points. Well, when you have a whole bunch of people, that 2 points is statistically significant. That's why we always look for statistical significance between things. And we see 8th grade trend starting in 98, statistically significant decline, statistically significant increase from 92 to 19. And this is 12th grade, statistically significant decrease, and increase. So we always look for that statistical significance in reading scores. Statistical significance from 2012, and we see the scores going up from 04 to 12, scores going up, and we look for that statistical significance always. In educational research, 2 different levels of statistical significance, p equals 0.05, p equals 0.01. What does that mean? P equals 0.05, 5% of the differences is due to chance or sampling error. And we usually use one of these two. So this is pretty good, but that's even better. P equals 0.01, 1% of the differences is due to chance or sampling error. So that's statistically significant. So we look for these things. And participants, we look for this. When we see that it's not significant, the difference between initial and the reevaluation, not significant. Initial, reevaluation, not significant. Initial and reevaluation, that is statistically significant. That's why I always have to go to the data. We look for significance. We look for the statistically significant differences. Smaller sampling size, of course, it's harder to find statistical significance if we had a sampling size of 3,000 versus 30. And the t-test automatically adjusts for sample size. So in reading different research, we always look for statistical significant differences. And this shows, again, the difference between doing a study and conducting research. You can collect data and do a study and find differences between one thing or the other. But we then subject our study to peer review, and research is not research unless and until it has been subjected to blind peer review. Differences are not important unless they are statistically significant differences.